Hello, and welcome to Los Alamos National Laboratory's Math and Science Academy.
In this example, we'll be looking at Common Core Standard for Mathematics, Grade 4, understanding a multiple of a over b as a multiple of unit fractions 1 over b, and using that understanding to multiply fractions by a whole number. The learning goals for this standard are to visualize and understand multiplication of a whole number by a fraction by looking at whole number multiples of unit fractions. The student will be able to fluently use multiple strategies, including area models and number lines, as well as symbolic notation. Finally, the student will communicate mathematical thinking precisely and correctly. So here's the problem that we'll use to represent multiplying a whole number by a fraction. The whole number we'll use is 3. The fraction is 2/5, and we want the students to recognize and understand that this is the same as using the whole number 6 times the unit fraction 1/5, and that ultimately the product is 6/5. We'll generalize this later to talk about any whole number and any fraction. So we'll begin with an area model, and for the area model we will start with a light green bar that represents one whole. If we break this into 5 equally sized pieces, we get 1/5. So 2/5 is represented as 2 of those fifths, and we shade them dark green here, and we can see symbolically 2/5 and symbolically 1/5 as well. To do the multiply, we want 3 of these sets of 2/5, and so we basically replicate that picture 2 more times, and now we have the graphical representation of 3 times 2/5, and we can write that symbolically as 3 times 2/5 this way. Now if we take this out of the context of the light green holes, we see that the shaded parts are equivalent to these 6 shaded regions, which are 6 units, each of which is 1/5. So this is 6/5, and we can represent it symbolically with 6/5. So what we've done is we've looked at images to support the concept and really try to focus on the images and concepts. In this particular example, there's not much in the way of procedure, and the language is pretty straightforward. We did use the fact that 3 times 2 is 6, or if you do it in an addition way, then 2 plus 2 plus 2 is 6. But we're always looking at ways to use images, concepts, facts, and language to support procedures, which are kind of our ultimate abstract version of things. Okay, let's look at that problem again, this time from the point of view of using a number line. Again, the problem, we're trying to multiply 3 times 2/5 and recognize it as 6 times 1/5 or 6/5. The number line, we begin by drawing it and conveniently break it into sections of 1/5 of fifths, which are evenly spaced 5 to a whole unit. So 1/5 is represented by one of these segments, one of these intervals. Therefore 2/5 is represented by 2 of those intervals, either graphically or symbolically, however you'd like to look at it. And then if we want to do 3 times 2/5, we want to replicate this 2/5 here 2 more times. And so we add 2 more 2/5 to our shaded region, and if you count them all up, you'll see that we have 1, 2, 3, 4, 5, 6/5, which of course ends up at 6/5 on the number line, and we can look at the entire distance as 6/5, either graphically again or symbolically with 6 and 5. Again, we've used images to support the concept, but a little bit more abstraction now that we're using a number line, specifically a number line that's broken into pieces of fifths. So it's a little bit more abstract, and we can see both the whole numbers and the fractions within the number line. Once we've introduced the problem through images and really the student really understands the concept, we can begin to look at symbolic solutions. So again, we start with the same problem. We're going to multiply the whole number 3 times the fraction 2/5 and recognize it as 6 times a fifth and get the product 6/5. So 3 times 2/5 literally means add 2/5 together 3 times. Or if we think of multiplication as repeated addition, we have 2/5 plus 2/5 plus 2/5 is 3 times 2/5. Because there's a common denominator, it means that the units being added are the same. The units are fifths, and we have 2 of them in each of these terms of the sum. And therefore, we can simply add the numerators, or we have 2 plus 2 plus 2, or 6 units, and each of the units is a fifth. And so we have 6 of them, and that means we have 3 times 2/5 is 2/5 plus 2/5 plus 2/5 here, or 2 plus 2 plus 2 fifths. It's really a grouping idea, and end up with 6/5. So in this formulation of the problem, we've really started to move towards procedures in much more abstractly. There's not a lot of image here. We're using a lot of symbols. There are facts. 2 plus 2 plus 2 is 6. And we're using language like denominator and numerator, which students need to understand. So finally, we'll talk about the most abstract approach, the most symbolic, where we can look at multiplying a whole number by a fraction as simply the same procedure. Now we're going to focus on procedure of multiplying the numerators and denominators of fractions together. So we notice that the whole number 3 can be written as 3 over 1. So the multiplication that we want to do is the same as 3 over 1 times 2 over 5. Students at this point may or may not know, but eventually will know the procedure that when we multiply 2 fractions, we multiply the numerators and the denominators independently, and this yields 3 times 2 in the numerator, which gives you 6, and 1 times 5 in the denominator, which gives you 5. In this case, there's no need to do any simplification or cross-canceling. It's a simple situation. And we're done. It's important as you think about generalizing this idea of multiplying whole numbers by fractions to not just generalize with the procedure, but rather go back with multiple examples of images and concepts going back to the area models and the number line models, and reinforce the concepts generally with multiple examples until the students can really see the pattern of what's going on. And as that emerges in their thinking, the procedure will become more and more obvious. So here's an example of a teacher solution for this problem. You'll notice that she starts with the problem statement up here, and then here's a version using fraction bars, where she's got the individual fifths, sets of 2/5 here, and multiplying that by 3 extends out to give you a total of 6 individual fifths. This should be a 5 here, 6 times 1/5, leaving 6/5. There's a second version of this that she has on a number line here, where she's showing the pieces, the 2/5 pieces, 3 of them, and then representing that graphically on an area model as well. Here, 3 times 2/5 being 6/5. So again, image, concepts, facts, language, and procedure to support all in a very small space.